One of the earlier shader videos that I made involved creating a blur effect in a shader. And as far as shaders to learn when you're first starting out go, blur effects are a pretty good one, I think. Conceptually, it's fairly straightforward. All we're going to do to make this effect happen is going to be to sample from adjacent pixels and take the average color of each of those pixels. And this is all done in the fragment shader. There's no nonsense happening in the vertex shader. And you can even pass in the radius of the blur as a uniform if you want, although in this case it's more of the half side length of a square surrounding each of the pixels rather than a radius. If you were to go into something like Photoshop, and if you were to take a random sampling of pixels in Photoshop, we will be essentially taking the average color of each pixel surrounding pixels, and that's fine. It produces the correct answer, but if you use this for any reasonably large blur radius, you're going to start to notice pretty quickly that it's not very efficient, and that is because the way that it's implemented here, the number of adjacent pixels that it has to sample goes up with the square of the blur radius. If you're into runtime analysis, we would consider that O of n squared. The exact number of texture fetches happening here is going to be 2 times the radius plus 1, the quantity raised to the second power. And I've whipped up a little sample program here where I can have this picture of my rabbit, and I can increase the blurriness of the image. Let me change the color of that text to like blue or something to make it easier to read. Hang on. Draw text. Anyway, we have the max frame rate displayed on the screen here, and I've also calculated the number of texture fetches for any given blur radius. If I were to make it go up, we can see that the image is getting blurrier, indeed, and the number of texture fetches required is going up with the square of the blurriness value, and my max frame rate. And if I was going to say that if I were to check the GPU usage tab in Task Manager, you would have seen that the GPU utilization for that little one GameMaker project would have shot up just through the roof as I did that. But as it happened, this actually overloaded my old GTX 1060 and my recording crashed right when I was about to say that. So good job, me. Obviously, exactly how far you can go with that before it will start to really make your computer fans sound like they're going to take off like a rocket will depend quite a lot on what GPU you actually have, but seems like a blur radius of 30 is about the limit for me. Anyway, assuming that you do sometimes want to have a blur effect in your GameMaker game, and assuming that you sometimes want to have a fairly large blur radius without completely overloading the player's graphics hardware, what can we do about this? So it's actually really common to only take a shader which is going to apply a blur in one direction. So this is just going to be this is just going to take the blur on the horizontal axis, so on horizontal pixels, and instead of doing the double loop, I'm just going to do a single loop, and it's going to be applied to the horizontal axis. At the end, I'm not going to scale that down by raising 2 times the blur radius to the second power. I'm just going to leave that alone. If I were to run this little, I don't want to call it a game, but this demo program now, and if I were to increase my blur radius. Okay, let's go all the way up to 30. Let's use 30 as my benchmark. That figure is not correct, by the way. But we can see that, well, 1, it's not crashing my recording. 2, this is a lot more performant than it was the first time I tried doing it when I was blurring it on both radii. However, it's creating a bit of a shear effect. It's creating a bit of like a motion blur, a horizontal motion blur effect, which usually not really what you want when you do a blur like this. Usually you do indeed want a blur to be applied on both the horizontal and vertical axes. We can, of course, instead of doing this on the horizontal axis, we can apply it on the vertical axis instead, and that will create the same motion blur effect, but the streaky lines will be more up and down than they will be left and right. Like this. That makes me a little dizzy to look at for too long. And of course, if you want to, you can combine these. You can do both of these at the same time. You can sample from both the horizontal and the vertical axis, combine them together. You will, of course, have to remember to double the quantity of textures that are fetched here. because it's the number of times the inner loop runs multiplied by 2. And if I were to run this, it should look a little bit, say, a little bit more balanced. I really should just edit the code so that I don't have to, like, manually increase the counter to 30 every time. And now we have a bit of a crosshatched effect. And this is definitely blurry, but it is, it's not the smooth blur that we had the first time when I was doing the double for loop, which was the one that was really causing the performance to tank. So clearly the ideal way to do a blur is to basically sample from each pixel in a box around the pixel that's actually being processed. So as counterintuitive as it sounds, it's actually quite a lot more efficient to, instead of doing a double for loop in the shader, in which you sample from each of the adjacent pixels on the original image, it's actually quite a lot more efficient to break this up into 2 steps. So firstly, I'm going to do the horizontal blur, and I'm going to blur the image horizontally, and let me rename the shader to shd_blur, and I'm just going to call that blur h for horizontal blur. And I'm going to duplicate that with a Control-D keyboard shortcut, or you can right-click and say duplicate. I'm going to call it shader_blur vertical, and here, this is where I'm going to do the vertical blur. So I'm going to sample from pixels on the vertical axis, go through the for loop once, take the average of all those colors. There were 2 times the blur radius plus 1 pixel sampled, and do this effect in 2 steps. Now, you can't have 2 shaders active at the same time. That is a fact which sometimes disappoints beginners, but when you get into what shaders are actually doing, it doesn't really make sense to have 2 shaders set at the same time. But what you can do if you want to apply multiple shader effects on top of each other, in this case, if I want to apply a horizontal blur and a vertical blur at the same time, I can create myself a surface. Let's call it, say, temporary surface. A surface create, which is going to be the size of which is going to be the width and height of my sprite that I'm drawing, the bunny sprite, the bunny image. I am going to surface set target onto that surface. I'm going to, I should probably draw clear just in case. I don't think that'll have an effect here. I'm going to draw the bunny with the horizontal blur onto it on this temporary surface. And then when we're done with that, surface reset target. And after that, I am going to draw the temporary surface onto the actual screen, onto the actual application surface at 0, 0. So that's going to be in the upper left corner. And then, of course, when I'm done, I want to surface free that so that we don't have surfaces just adding up in memory. Now, when we're drawing the temporary surface, this is where I'm going to copy some code, and instead of applying the horizontal blur shader, I'm going to apply the vertical blur shader, so shd_blur vertical, and reset the shader when I'm done. Alright, fine feather, we won't declare the variable twice. So to recap, I'm going to draw the original image onto a temporary surface with the horizontal blur. I'm going to take the temporary surface with the blurred image, and I'm going to draw it with a vertical blur. And in doing so, we're going to apply both the horizontal and vertical blur. And now when I run the game, and if I were to hike up the blurriness factor to, let's say, a radius of 30, then we have essentially the original blurred image, but it is performing much, much better than it was before. We're edging on 600 FPS here. If you have a GPU that's newer than, any GPU that's like newer than 7 years old, then you're probably going to be getting significantly better performance than this even. And that is because, despite the fact that we're doing twice as much drawing, like we're drawing the temporary surface, and we're setting the shader to the temporary surface, Both of these shaders, both of the shaders that we're using for horizontal and vertical blur are much more efficient than trying to do it all at the same time. And I should probably correct that that texture fetches calculation. So 30, a radius of 30 will be what? 30 times 2 plus 1 is 61 times 2 is 123. Is that what it is? That sounds about right. 122. That's right, it has to be an even number. Anyway, so if you've ever seen a blur shader implemented as a horizontal pass followed by a vertical pass, that's why. There are other ways to do blurs in shaders. There are radial blurs. There's a couple other techniques. Kawase blur is another one. Bokeh blur if you're interested in like camera, like depth of field effects. But a two-pass blur like this is pretty common, and you tend to see it in a lot of places. As to why this is so much more efficient despite producing the correct result, when we did this in one pass, we had to do what essentially boiled down to a lot of duplicated work. So for every pixel, we had to sample all the pixels around it, and then merge those values together into a final color. Whereas if you do this in two passes, first you just take the horizontal pixels, you do the horizontal blur, you save that information, and when you do the second pass, when you do the vertical blur, the horizontal blur information has now been encoded into each of the pixels, and you don't have to do it again for every single pixel. You just have to pass over it twice. You just have to pass over a second time. So now, if you're into runtime analysis, this is going to be a big O of n time complexity. So for each pixel, we only have to do the amount of pixels we have to sample for the blur factor only goes up linearly. It doesn't go up quadratically, which makes for a much more efficient algorithm, despite the fact that we have to actually draw the image twice. And then, of course, in this particular case, you could squeeze some additional performance out of this by, instead of making temporary surface a local variable that you declare in the draw event, you could save that for later and not free it every time. You don't have to reallocate and free it every time. Of course, if the player minimizes the game window or does something else to make the surface evaporate, you'll have to check that it still exists if you want it to work, but smart use of surfaces is another way to improve the performance of your game. If I minimize this, it'll crash, because the surfaces no longer exists after being minimized. But anyway, did I have that second window open the whole time? I think that's it. I would like to talk about other ways of doing blur and shaders at some point. I would like to do more like general shader videos that don't directly relate to 3D. This is something that's been like a long time coming. I kind of wanted to make it a long time ago when I did the original blur video as like an advanced version of that first video, but at the time I really wanted to do more 3D stuff and I kept putting this one off, and eventually I just kind of forgot about it. It's here now. If you want an efficient blur in GameMaker, this is how you would do it. My name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. I try to post about 2 game dev videos a week, one tutorial like this. I like to focus on the weird things you can do in GameMaker, featuring shaders and 3D stuff and that kind of thing. And one Let's Make a Game, currently a 3D Zelda-like wizard game. So if any of that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I hope you all found that useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Syndra Larson, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.